please.
Okay, good afternoon, everyone. Or
Good
good day,
afternoon.
depending on your location.
Yeah.
Adeyemi Olusola, and I'll be presenting on lithology and channel network initiation and orientation, a case study of Upper Ogun River Basin, Southwestern Nigeria. I'm also presenting this together with my supervisor, who is now late, Professor Adeyemi Olusola of the Department of Geography, University of Ibadan. Several studies have highlighted the importance of structure on landform evolution, and most of these studies have been carried out in temperate regions or in basins where we have glacial history, and they've been able to show extensively the interactions between process form dynamics, in the literature. However, there is still a lot to be done, especially for humid tropical basins without glacial history, especially for basins that are largely ungauged. Now, the problem here now is that information on basins within humid tropical region, especially for largely ungauged basins as we have in sub-Saharan Africa, is too limited for any reasonable and definitive inferences and deductions to be made. Hence, there is need for us to leverage on available big data, such as the digital elevation models, and then the emerging geocomputational tools. Now, what's the aim of this study? The aim is to understand the influence of lithology on river channel orientation. And here by lithology, I'm using the lineament patterns within each basins, and then trying to see if there's any relationship in appearance between lithology and then river channel orientation. To achieve the aim of this study, I'll be using digital elevation models, specifically SRTM at 30-meter resolution. And then I'll be using rose diagrams to highlight the influence of underlying lithological units on river channel network orientation, river channel network initiation. The study area is Upper Ogun River Basin. Ogun River Basin itself, this is the entire basin here on my right-hand side, is located within the southwestern Nigeria. And but I'm considering the upper part of the basin. The basin directly empties into the Atlantic Ocean, and it's a major basin in southwestern Nigeria. I identified 17 other basins using SRTM at 30-meter resolution, and these I validated using topographical maps covering the entire basin. Then I carried out geoprocessing techniques to extract the 17 channel networks using the field them from the hydrological tools of the R toolbox. The extracted channels were then ordered using the Strahler method. And these are the channels here using the Strahler method. And all I did was to now group the extracted channels based on underlying lithology using a systematic and random sampling technique. All I did was to ensure that the basins that were selected, there was no lithology that was beyond 70% covering each of those basins. So any basin that is not heterogeneous is dropped. Any basin that is not heterogeneous is dropped. Yes. So I was looking at basins that are heterogeneous, and then I defined being heterogeneous as having lithology that is not above 60%. Then I randomly select the available ones, and I have 6 basins, and these are the 6 basins here that were used for the study. Topographical properties were extracted using the Saga, while Rockworks was used in creating the rose diagram. Now this is the rose diagram for the fault lines, and then also for the channel networks within each of the 6 basins. Now, rose diagrams present the influence of underlying lithological units on river network orientation. Rose diagram presents the influence of underlying lithological units on river network orientation. There has been established that known methods of relating lineament patterns to morphotectonic subsets could be done using Rose diagrams. And the frequency and length of lineaments as presented in this study and as presented in this study using Rose diagram shows a bimodal distribution in most cases along the east-west and north-south, and then along the north-south directions. And the distributions of this east-west, north-south, and north-south have corresponding peaks on the length orientation axis of the Rose axis of the Rose diagram of the river channels. Now, this has implications. Actually, what we did next was to disaggregate this across each of the basins, and then we were able to identify, some commonalities as regards this trend and this distribution. In conclusion, we observed that, from the Rose diagram, that 4 major lineament trends, exists within the entire basin considered. This is the east-west, the north-south, the south-southeast, south-southwest, and the northeast-southwest. And across these 4 major trends, the north-south and the east-west were particularly dominant. Now, the general trend of tectonic grains, this has been established, from some studies in the country, that the general trend of tectonic grains within the Nigerian basement complex is relatively in the north-south trend. And as also observed, within this study, we also noticed that the north-south trend is also dominant together with the east-west. And then we were able to infer that the main channels draining the selected basins in Upper Ogun River Basin appear to have been controlled along pre-existing weak zones in the country. And geomorphologically, the east-west and the north-south lineament trend, as observed in this study, can be tied to tectonic events that have affected the evolution of the Upper Ogun River Basin. Also, we were able to establish that we can imply that these 2 lineament orientation sets, that's the northwest and the east-west, could define the preferred orientation of groundwater occurrence within the Upper Ogun River Basin. And while another far-reaching implication is that the observation of the occurrence of the northwest and east-west trending lineaments in the area might suggest that they serve as active conduits connecting most springs in the study area to the main channel. Thank you very much for listening.